Okay, here we go. Today we're finding the probability of disjoint and overlapping events, and sometimes that can get a little bit tricky at times because things will happen in conjunction with each other. So, and as we go through, you'll kind of see what those look like. A compound event is a union or an intersection of two events. So we're just going to say union of two events. That's a compound. And then disjoint would be when there's nothing in common with those things. Nothing in common. Two things that have no bearing on one another. Okay? The probability of compound events, if A and B are two events, then the probability of A or B. Remember earlier we said that or thing, right? And so when we had the or thing, we talked about the probability of A plus the probability of B was the plus sign, right? But when they are compound events, means they overlap a little bit, you have to subtract the and. You have to subtract with the A and B, the probability of A and B. So things that are compound events, what's the chances of drawing a 6 or a heart? Well, you have the probability of drawing a 6 and you have the probability of drawing hearts, but you have to subtract the 6 of hearts because that's a compound event. And when you have a probability of disjoint events, you don't have to worry about subtracting that other thing, okay, because they don't cross over. What's the probability of drawing a 6 or a 7? Well, you don't have that crossover there, so that works out. Okay. Let's take a look at this number cube. You roll a 6-sided number cube or a die. What is the probability of rolling a 2 or a 5? And so let's say you win $1 million if you can roll a 2 or a 5. There's one outcome for a 2 and there's one outcome for a 5. Because you can't roll a 2 and a 5, there's no combination of them. We call them disjoint. They don't overlap. So it's just the probability of A plus the probability of B. Okay? Which is 1/6 plus 1/6. If we add 1/6 plus 1/6, we get 2/6, which reduces to 1/3, or the probability becomes 0.3 repeating. All right. What do you think about it? What's the probability that you could roll a 1 or an even number? See, 1 is odd, so that's disjoint. So go ahead and see what you think. All right. Hopefully you got 1 out of 6 for rolling a 1, 3 out of 6 for rolling even numbers, ends up being 4 out of 6, or 2/3. 2/3 for that one. Hopefully that makes sense. All right, let's take a look at it. On this page here, this is the compound event. So this is where it gets a little bit more difficult. You roll a 6-sided number cube. What's the probability of rolling an odd number or a number less than 3? Less than 3. Okay, numbers less than 3, 1 and 2, by the way. Odd numbers, 1, 3, and 5. Okay? Let event A be the rolling the odd number and B be the rolling the number less than 3. A has 3 outcomes. B has 2 outcomes. Of these, one of their outcomes is the same. Okay, so we have when we go to figure out this probability, you have a 3 out of 6 chance plus a 2 out of 6 chance minus a 1 out of 6 chance. Okay, so you have a 3 plus 2 is 5, minus 1 is 4 out of 6, or 2/3, or 0.6. Now, if you made a mistake there, you might find that when you add your 3 plus your 2, you had a 5/6 chance of winning. Let's put this whole thing in a big, so we know that this is not what Mr. Emmeott's saying. This is what you made a mistake. You have a 5/6 chance of winning if you added that together. Well, there's two numbers that could have been, we'd have lost, the 4 and the 6. So if we'd have just thought, okay, what could not be in this group? 2 numbers. Well, then we'd have known right away that gives us a 4 out of 6 chance. Okay, let's take a look. These next guys here. Music. In a survey, 300 students, of 300 students, all right, 150 of them like pop music, 150 of them like pop music or country music. Then 97 students who like pop music, and we're talking about pop music, we're talking about the original MJ. When we're talking about country music, we might be talking about somebody like Kenny Chesney. What is the probability that there are 97 students who like pop music, and there are 83 students who like country music. What is the probability that a randomly selected student likes both pop and country? And we're talking about both. I don't know. My best guess is Taylor Swift, but you guys probably have a better idea than I do. So if we take a look at that scenario there, we're going to let event A be selecting a student who likes pop music, and B be the student who likes country music. All right. So it's possible to like both. So let's keep that in mind. So you have 97 over 300 people. Those were our pop music, and 83 over 300 who liked country music. And then the probability of A or B, you see we had that or in the beginning, they like pop music or country music, was 150 out of 300. Okay. The probability that a randomly selected student likes both pop and country music would then be the probability of A or B. Well, it is the probability of A and B. So the probability of A or B would be the probability of A plus the probability of B minus the probability of A and B. Alright, now this is where it gets tricky. Okay? I know the probability of A or B. I know that. They told that to me. So that's 150 out of 300 right here. Okay? And I know the probability of A was 97 out of 300. And I know the probability of B was 83 out of 300. The missing, the unknown, was the probability of A and B. So I'm going to call that X. That's what I'm trying to find. Okay. So if I add X to this side, so if I add probability of A and B to this side, and I subtract this to the other side, I end up with 97 over 300 plus 83 over 300 minus the 150 over 300. So I just flip-flopped those two things, trying to solve for probability at A and B. Well, 97 plus 83 ends up being 180. 180 minus 150. 97 plus 83 was 180. Minus 150 was 30. So I have 30 over 300. Or 3 over 30. Or 1 over 10. Or a 10% chance that somebody likes both pop and country. Alright, hopefully I made that as clear as I could, but the hard part is right when you're switching from the A and B's to the A or B, so you don't know which piece they're going to give you. Alright, so here we are, we're taking a look at example 4, and it says when two 6-sided dice are rolled, now we're not calling them number cubes anymore, apparently we're calling them dice. There are 36 possible outcomes, and you guys have seen that table a bunch of times probably. When you have, you have the two dice, and there's a 1 and there's a a 4 and a 4 and a 1, and so there ends up being 36 different things that can happen. What we have here is when 2 dice are rolled. All right, here's that. I went out onto the internet and grabbed that table real quick so I can show you a little faster. So when we're looking at this table, and I guess it's not the clearest table that I could have got, but at least you can kind of make sense of it. You can roll a 2 one way. So you have a 1 in 36 chance of rolling a 2. And you can roll a 3 two different ways, a 1 or a 2, or a 2 and a 1. And that's the part that kind of confuses people. Think about the 1 being a black dice and the 2 being a white dice. And then when you roll that die again, it could be a 2 on the black side and a 1 on the white side. And that gives you that other opportunity. So the sum of rolling a 4, and it's hard to read there, but there's 3 different ways to roll a 4. So the sum of not rolling a 4 would be all the things besides a 4. So if it's 3 out of 36 to roll a 4, then the sum of not rolling a 4 would be 1 minus 3 out of 36. Or if you called the 1 36 over 36 minus 3 out of 36, you'd get 33 over 36. And if you'd reduce that, you'd get 11/12 out of that, or 0.917. Okay? And the probability of rolling a sum that's greater than 3, well, things that are less than 3, greater than or equal to 3, things that are less than 3 only leaves us with the 2. And so you really have 35 out of 36 ways that you can roll a sum of greater than or equal to 3, 0.972. And what we're working with there is the concept of complements. We're saying, what's the, let's just take away the things that don't exist so we can get the things that do exist. So the complement of something is this next concept here, and I'm going to kind of just move those pictures aside for just a minute. The complement is not. Now, when I was a kid, we used to say things, not was a big word. Not, I love you, not. It always got me out of a lot of trouble. Just kidding, not. So when we say find the probability of not A, we do 1 minus the probability of A. Not. Right? Just like that. Okay, you guys take a look at these checkpoints here real quick. See if you can do those. All right, welcome back. You roll a 6-sided number cube. What is the probability of rolling a number less than 4 or an even number? All right, numbers less than 4. Those would be 1, 2, and 3. Even numbers, 2, 4, and 6. So I have a 3 out of 6 chance of rolling a number less than 3, plus a 3 out of 6 chance of rolling a number that's even. However, look at this. I have a crossover. So I have to subtract 1 out of 6, and I'm left with 5 out of 6. And hopefully somebody out there is saying, yeah, because you don't have the number 5. You never had the number 5 involved in your thing. 1, 2, 3, 4, 6, but there is no 5. You double counted the 2. All right. On this next one, 3 out of 25 is what that ended up being, and you worked it out the same way as the music problem. And the probability sum that is not 8, if you had the sum that was not 8, if you look at, oh boy, that whole thing's shifting around, isn't it? The sum that is not 8, well, you had, let's look real quick, let's sneak over 1, 2, 3, 4, 5 different ways to get an 8. So, not 8 would be 31 out of 36. So remember, that's that whole complement thing. If it's the not 8, 1 minus 3 out of 36 gives you 31 out of 36. All right. Thanks a lot, folks. That's all for 10.4.